Hello, I'm Mr. Dady, and today we're going to talk about scientific notation. Alright, scientific notation is the method of writing very large or small numbers as a product of a number greater than or equal to 1 and less than 10 multiplied by a power of 10. Basically, it's a fancy way of writing a number. Alright, so how we do this? This is our first example. So here I have 0.0025. Right? So what I'm going to do is I'm going to move the decimal over to make this a number in scientific notation. All right. So what I want here, one, is I want the lead number all right, I want that lead number to be between 1 and 9. Alright, so the very first number you're going to have in scientific notation is always going to be between 1 and 9. It's not going to be 0, and it's not going to be 20. It's not going to be 10. Alright, between 1 and 9. So what do I have to do to get the lead number here to be between 1 and 9? I have to move the decimal. Alright, so 1, 2, 3 places. So every time you move, you have to count it. So I'm moving my decimal place on this side of that digit, right? That was moved once. I moved it again, twice. Moved it to the next one, 3. So now what I want to do is rewrite it after that. So move decimal, and rewrite. So now I have 2.5. Now I just can't move a decimal and say, oh, this number is the same as this. It's not. We have to add something to it. In this case, a times 10. But now this is why we just did exponents. So exponents is scientific notation. Right, so our third part is add times 10 to some exponent. All right, so now, since we moved the decimal to the right, so when you move it to the right at the beginning, you're going to have a negative exponent. If I move it to the left, I'm going to have a positive exponent. Right? So I moved it 3 places, and because I went to the right, negative 3. Right? So if you want to, so there you are. Let's do another example. All right, for example number 2. 5,601. We want to switch this to scientific notation. So I don't see a decimal point, you might be asking. If you don't see the decimal point, that means it's always behind the ones place. All right, so now we're going to change this. But our first thing we have to do is our lead number has to be between 1 and 9. Our lead number right now in front of it is 5,601. So we move it 1 time in front of the 1. Is that between 1 and 9? No. So we move it again. Is 56 between 1 and 9? No. So we move it again. Is 5 between 1 and 9? Yes, it is. So we move this 1, 2, 3 times. Is how many times we moved it. All right? So now we're going to rewrite it. So move decimal and rewrite. Step 2. 5.601. Now to our next step, we add in times 10 to some power. So I move the decimal to the left. So when I moved it to the left, that means my number up here is going to be positive. How many times did I move it? 3. I'm going to do another example. All right, example number 3. We have a very big number. We don't see the decimal anywhere, so we know it's behind the ones place. So our first step, lead number has to be between 1 and 9. So, is that between 1 and 9? No, 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 no. We're good now. 2 is in between 1 and 9. Alright, then we moved it 1, 2, 3, 4, 5, 6 times. So, part 2. Well, I should keep my red marker out. We moved the decimal, so now it's 2.654309. The only thing we did different is we moved the decimal to where it needs to be. So now the lead number is between 1 and 9. We moved the decimal and we rewrote it. Now for step 3, we do a times 10. But to what number? Alright, we move the decimal this direction, which is left. So I'm going to have a positive exponent. So positive what? 6. There's your answer. I'm going to do another example. Example something, I don't remember now. So our lead number is 0. We need to get it between 1 and 9. So let's move that decimal. 1, 2, 3, 4, 5. Is 9 between 1 and 9? Yes, it's 9, so it's in between it, it's with it. So I rewrite it as 9.1. Okay. Now, we did our second step, we moved the decimal and we rewrote. Now we have to add our 10 times 10, but to what? What exponent is it raised to? So we moved it 1, 2, 3, 4, 5 times. But is it positive or negative? We moved the decimal to the right, so it's negative. Negative 5. And that is our answer. If you follow those steps, it's not very difficult to change it from scientific, or this is called standard form, to scientific notation. Now I'm going to show you the way to go the other way. So if you have something in scientific notation, how do you put it in standard form? Step 1, when you're going from scientific notation to standard form, you need to know which direction am I going to move the decimal. So we have a positive, so this one is opposite. When you have a positive, you're going to move to the right. So a positive exponent moves to the right. A negative exponent, you're going to move to the left. All right? Please write this down, as you should have written down the other thing. Keep a note of it, which one you're going to. So this is scientific notation to standard form. The other one was standard form to scientific notation. All right? So which direction am I traveling? So I have a positive exponent. So our exponent is just this up there. I'm just writing it down as n if you didn't notice. Yeah, I hope you did, because now it's a little bit too late. All right, so now which direction am I going? Positive, I'm moving to the right. So how many times do I move to the right? 3. 1, 2, 3. All right, so now my decimal is there. So our step 2, move decimal, and rewrite. Right, which is the same step as the other one. So now I get 2,568. And that's it. That's your answer. This was a pretty simple. All right, we're going to do some more now. All right, our next example from going from scientific notation to standard form. So which direction am I moving? I have a positive exponent, so I'm going to move my decimal to the right. All right, so how many times am I going to move it to the right? 5. 1, 2, 3, 4, 5. But oh no, there's no numbers there. What am I to do now? But wait, you put in zeros. So all of those that you didn't get to move, you just add zeros. And that is our next step. Add zeros when needed. So whenever you have a blank place, no matter if you're going right or left, you just put a zero in it. So now my final answer is 5,800,000. 5,580,000. That is how you do that. Now I'm going to do more examples for you. All right. Uh-oh, we have a negative now. Woo! We do it the same way though. Don't worry. Negative does not mean this is negative. I get that a lot. Whenever someone sees a negative exponent, they're like, oh, this means it's negative 9. It's not. Negative just means you go the other direction. So I have a negative exponent, so I'm going to the left this time. How many times am I going to the left? 3. 1, 2, 3. And now, I'm going to rewrite it. So 9, 5, 1. Then I have to add zeros. 1, 2 zeros. And there you go. That is your answer. 0.00951 is your final answer for this one. It's done the same way as the other one, you're just moving the other direction. Alright, last example. So which direction am I moving? I have a negative exponent, so I'm going to move to the left. How many times? 6. I'm going to write it over here, just so I don't run into my thing over here. So 1, 2, 3, 4, 5, 6. Now instead of rewriting it, I'm going to write my zeros first. There we go. So now my answer is 0, 0, 0, 0, 0, 6, 5, 4. That is how you go from scientific notation to standard form with both negative and positive exponents. I hope this helped. I hope these rules help. I'll write this down while you're doing it so you don't get it confused between going from scientific notation to standard form and standard form to scientific notation. That's very easy to get confused. I hope this helped out, and good luck.